Together with the apparent resistivity and chargeability, the Syscal Terra allows you to save the time series in background. They are contained in this HRW file. Let's discover how the reprocessing of time series in your computer can help you to improve the quality of your dataset. Let's start by opening the standard RPP data file containing apparent resistivity and chargeability. So if you have a look at the sort of section of chargeability, you can see that the second level contains negative apparent chargeability up to -2 millivolts per volt. This effect, known as electrode polarization, is due to the use of a reception electrode that was previously an injection electrode. In that case, the second level of IP measurement cannot be used for the inversion. The user will have to reject this measurement, creating a lack of sensitivity and resolution in this area. Let's see how to correct for this effect in Process using advanced algorithm developed by Iris Instruments. You simply have to click in Processing, then Full Wave Processing. Two windows will appear. The first one on the left allows you to select the algorithm to use. They are pre-selected for you. And the second window just defines the data to compute. By default, it is the entire dataset. So click on Compute. A new Binix file will be automatically created and the window will be automatically open. So I will place this window on the right side of the screen and keep the initial dataset on the left side. You can plot the two chargeability dataset. Again, on the left, the one coming directly from the Syscal Terra, and on the right, the one reprocessed on your computer. And you can see that the effect of electrode polarization on the second level has been entirely corrected, showing only positive apparent chargeability values. This new dataset can be properly exported and inverted in your inversion software. During the processing, one can see that the H5 file has been created. It contains both time series and apparent resistivity and chargeability computed. So you can open this file in Process. You can right-click on any line you want and select Show IAB and VMN file. The time series associated to the selected line will be displayed automatically, allowing a visualization of your data and a deeper quality control. But you can also choose to visualize your dataset injection by injection and channel by channel directly in FullWaveViewer 2. This kind of visualization will allow you to detect and understand the different phenomena occurring during a measurement, like electrode polarization, electromagnetic induction, or simply a low signal-to-noise ratio. In addition to this helpful quality control, it will be useful also to understand the condition of occurrence of this phenomenon and to increase your expertise in avoiding them on the field. A second interesting feature is linked to the on-time IP measurement. You know that it is possible to measure IP during the off time, but also during the on time, so during the injection. Here are two files, one called off-row IP, containing off-time IP. It has been acquired in 50% duty cycle mode with a 2-second pulse injection. If you look at the IP pseudo section, you can see a shallow chargeable layer with a chargeability up to 15-16 millivolts per volt. This is a sandy clay layer, and after 30 meters of depth, a limestone formation becomes less chargeable between 0 and 1 millivolt per volt. If you now open the same IP data file, but acquired during the on time, so in 100% duty cycle mode with a 2-second injection pulse, you can see that on-time IP measured with a Syscal or Terra has a specificity. Indeed, the data acquired is a charging curve because we are measuring during the injection. So we have to transform this charging curve into a decay curve. To do so, we compute VDC and then compute the VDC minus charging curve to get the decay curve. The point is that we don't know VDC, so we approximate it as the voltage value measured at t equal 2 seconds. As a consequence, decay curve obtained always ends at 0. If you look at the chargeability windows, number 20, it is always equal to 0. Now, if you look at the chargeability pseudo section, the on-time chargeability is always lower, with maximal value of 10 millivolt per volt compared to 15 or 16 millivolt per volt previously. The difference of amplitude is due to a bad transformation of the charging curve to a decay curve because we don't know the VDC value that should be measured way after 2 seconds. So to correct for this problem, Process 3 features an algorithm to better estimate the VDC value and greatly improve the transformation of the charging curve to decay curve so that it doesn't end at 0 millivolt per volt. To activate this feature, you just have to click on Rising IP Correction. From the charging curve, the software is now computing new decay curve that will not end at 0 millivolt per volt. And this will take approximately 30 seconds in such a dataset. If you now look at the IP pseudo section, except 1 or 2 negative data points, you can see that the IP is now ranging from 0 to 16 millivolt per volt, which is very comparable to the off-time IP. Thanks to this feature, you can now use on-time IP as it was off-time IP.